All right, welcome everybody. This is testing best practices. I am Randy Syring, and we're going to go ahead and get started. Little bit of background from me. I'm a chief executive developer at Level 12. Level 12 is a custom software consulting company. I've been doing that for about 15 years, doing primarily database-driven web applications. About 12 of those years have been in Python. None of our apps are at scale. I don't have anything running like Google or Facebook or really even anything that from a web front end has more than one front end to it. Our applications are more typically complex business user applications with a lot of custom business logic, serving a relatively small number of clients, but doing a lot of the heavy lifting for them. So your mileage may vary if you're working in an environment where you've got a large team or you're working at scale. Some of the techniques that I'm going to show you here might need to be rethought in terms of how you do your tests. Then again, we do have one app that's about 10 years old and has 111,000 lines of code, Python code, and has 97% test coverage. And the best practices I'm going to show you here are at the core of that application and have resulted us being able to continually improve the tests in that application as it has been, as it's grown over time. So the things that we're doing here definitely have longevity and can help. Okay, so I see we got some people running into problems. I'm going to address that here in just a little bit if possible. But the first thing I want to do is I want to focus a little bit on just automated testing in general, and this is where I want to get some, I hopefully want to get some interaction. So one of the things I want to know is, in your experience, why is automated testing hard? Go ahead and raise your hand in the Zoom meeting or at me in the Slack channel if you'd like to contribute and explain why you think automated testing is hard, or maybe why you get some pushback in your work environment on people maybe not wanting automated tests. What's the perception of automated tests? Is it generally positive, generally negative, kind of mixed? What do you think? Okay, so we had Michael say that because Jenkins is hard, so maybe automated tests aren't hard, but continuous integration is hard. Adam says that it takes a while to build the tests, so that's certainly a possibility. Slowness can often make tests hard to run. I'm sorry, I don't know exactly how to pronounce your name, but Maxim has raised their hand. Go ahead and join. Go ahead and unmute yourself and tell me why you think tests are hard.
Yeah, hi. Well, more automated tests. Main reason is because you can automate most of the things around them, but you cannot do exploratory testing with that. And this part that it's hard to automate and sometimes impossible.
Okay, so they can be hard to maintain. Okay, thanks for contributing. Let's see, what else do we got? Interesting tests interact with other services, which are changeable state and hard to check. Exactly. So that is one of the main reasons why testing is difficult. Is a lot of your interesting tests end up crossing application boundaries to other services, and if you don't have good paradigms in place for how to handle that, it could definitely be a point of brittleness. Adam, go ahead and join the conversation here. What do you think?
So I commonly run into problems where I'm trying to mock external services, and that's like trying to figure out how to set up your tests to deal with other people's services that change. That's where I run into problems.
Yep, makes sense. Okay, we've got somebody else talking about CI. It takes 30 to 40 minutes to run, so that's really interesting. We've got that application that I mentioned earlier that has 111,000 lines of tests or lines of code. We have the same thing. Our CI takes, it used to take almost an hour for it to run. And one of the ways that we solved that was by parallelizing our CI. So we did have to do a little work in the app for the tests to make sure that they could run that way. But then we basically split it out over 4 workers. So it still takes 10 to 15 minutes to run the entire CI. but you know, that was an okay trade-off. CI/CD lifecycle, we see some mocking. Yep, I see all those things. Okay, good. I'm going to go ahead and keep going here. So one of the main ideas that I have in tests is that tests are either tests are one of three things. They're either an expense, an asset, or a liability. So let's talk about that for just a second. When I usually like to take an audience survey when I'm doing this live, and I'll ask people how many people test their code. And because I'm in an automated testing workshop, a lot of people don't raise their hand because they don't have automated tests. But the reality is most people are not just writing code and then immediately shipping it to production. Either they're testing it themselves when they're writing it, or they have some kind of QA team that's testing it by hand, maybe a mixture of both, maybe mixed in with some automated tests. And so most people are going to test their code somehow. The point that I want to make is that if you're testing things manually, every time that you test, it's like spending money. I've spent it. I'm not going to get it back. I'm not putting it in savings. I'm not building an asset. I'm just spending it. And the reason that it's an expense is because you're going to have to do the same test over and over again. So if I test it manually today and I go back to that code tomorrow and I change something, I'm going to have to rerun all of those tests manually if I want to make sure I haven't broke something. And as you know, software often gets more complex, not less. And so it becomes harder and harder and harder to test manually, which usually results in maybe a handful of critical path tests that, or it results in really slow release cycles because it just takes too much time. So testing manually is an expense. Writing automated tests is better, but it doesn't automatically mean that it's, or writing automated tests can be better, but that doesn't always mean that it is better. It's not necessarily better. And the reason for that is if you have automated tests that are brittle or otherwise just difficult to run or manage, then instead of being an expense, they become a liability. So you still might have the ability to run automated tests, but instead of increasing your productivity, they're decreasing your productivity. They're becoming a liability. And so we don't want that from tests either. What we want from tests is for them to be an asset. We want them to be something that over time is making us more productive, is contributing, if you will, ROI or return on investment. And so that the developers in a project should say, I love our tests. I couldn't imagine developing without them. That's really where you want tests to be. And when they're like that, then they're considered an asset and not a liability. Yeah, so there's a lot of places that will just have QA teams test and won't actually invest in automated tests. And really that's that's kind of a business level decision that a lot of times developers just aren't in a place to contribute to or affect change, unfortunately. Okay, so any thoughts about testing as expense, asset, or liability? Go ahead and raise your hand or Slack at me in the Slack channel. We'll try to get some comments going here. Yeah, Adam, go ahead.
Just in regards to a liability, one thing that at least beyond Python and like Salesforce platform, for example, some of our previous tests that have been set up weren't set up correctly, and even after making changes, our tests would be passing, and we'd find out later that bugs were still present in the code at that point, and it's like, well,
Sure.
okay, our tests weren't really helping us there.
Yep, I've been in that situation before where I've had something under test and it turns out I realized later that I wasn't testing what I thought I was testing. One of the best ways to make sure that doesn't happen is to use a TDD process whereby the first test that you write should fail, and then you make one small change in your code and that test passes. That's not always foolproof, but I would say that methodology will prevent the I thought I was testing something, but I was actually testing something else type of accidents. you know, probably, I don't know, just rough statistics, 70–80% of the time, that type of pattern is going to help you. Let's see, we got anybody on Slack? Nope. Okay, so Maxim, go ahead, and you'll have to tell me if I'm pronouncing your name correctly. I'll try to get it right if I'm not.
Oh yeah, you're pronouncing it perfectly fine.
Okay, great, thanks.
Anyway, I think that tests are asset, and usually in my practice we use it more like a design tool or a way to develop things, because it's much faster to create a test ahead, and especially high-level test, and then to make sure that the logic that you coding is working correctly, rather than going through all the steps manually and trying to see if it works or not. You have already a test there that does it much faster. And of course, once again, I cannot emphasize enough how much improved tests your code design.
Yep. Okay. I realize I'm seeing some. Okay, Chris jumped in and said, I have a hard time knowing how my tests, what my tests aren't covering. Are there pathways I'm not thinking of? So that's definitely something that can be in some ways paralyzing sometimes, to be wanting to write not efficient, sufficient tests to sufficient test coverage. It is helpful to have a coverage analysis tool. We use codecov.io for that, and we bake that right into our CI and our GitHub pull requests. So seeing the code coverage right in the pull request makes it pretty easy to know when coverage is dropping or not, and what's covered and what's not. It's not 100%. You can still have bugs. You can still have you know, all of your code covered and still have bugs, but code coverage can go a long way towards answering the question, did I check that code path with a test? You know, is it valid? The other thing that it's been handy to do is sometimes I copy and paste a lot of my test methods, and sometimes I'll forget to rename the test method, and I'll have this big white spot in my code coverage where I see one method isn't running. It's because I forgot to name it. That actually hasn't happened recently because we use Flake 8 now and fail if Flake 8 doesn't pass, and it would fail that condition. But it's still useful to do code coverage on your tests as well. Okay, just so everybody knows, I am finding it a bit difficult to track everything that's happening in Zoom. So if you're still having problems getting your environment up and running, please forgive me. I'm not able to really contribute there at the moment. I'll pause here in just a second, in a few minutes, and see if there's anybody who needs some help. One of the things we're going to have to do here, one of the difficulties with the tutorial is that you have people with varying levels of skill. And so just keep in mind that we may not be able to get to everybody. If you're falling behind, there will be pauses where I'll be able to catch up. And if you're advanced and you're ahead, feel free to jump in on Slack channel and try to help out your neighbor if you see a problem and you think you can help them get it running. Just FYI, I'm not going to be able to track the Zoom comments. That's just one too many screens to look. So if you want to make comments, please leave them in the Slack channel. Okay, a few more comments about testing, and then we're gonna jump into the interactive tutorial. There's a handful of things that we can do to help our testing be consistent. And so one of the, to help it be an asset. One of those things is that they should be easy to set up. And so for those of you who have started the tests, I realize that some of you are having problems, but in general, it should have been pretty easy to set up the tests. My dependencies were declared, both in terms of Python dependencies in the requirements file. The service dependencies were declared using Docker Compose. And you had very simple test instructions. Basically, check it out, do a pip install, get Docker Compose running, and then run pytest, and they should pass. That's what you want to do for your applications. They should be that simple for any developer to check them out and run them. Now, if you are operating at scale, there may be certain types of tests that you can't run. For example, you may your CI may have performance tests where they kick off maybe, 3 tools that do stress testing. Those type of tests may not be able to be easily reproduced on a local system due to resource constraints. But the majority of your tests, the majority of your back-end and front-end tests should be easily ran on a developer machine with relatively little environment set up. If I had had more time, I also would have added Tox and CI to this project. Which means that any developer should be able to come in, and by simply looking at how Tox and CI is set up, they should be able to get their own machine running. And there should never be any question in an application about how do I run these tests. The combination of the CI setup, Tox for a Python application, and first instructions in a README are always how do you get the test running, because that just gives your developer who's jumping into a project, it just gives them a really high level of confidence that as they go and maybe go to pick up an issue and start working on something, that if they've broken something, it's their fault. And it's not their test setup. They've not done something wrong with the test setup. So high confidence level that the app is running is accomplished by easy checkout of the repo and easy start and 100% completion of all your tests in the project. There's another issue with tests, and that is we always want success or failure. We want to avoid intermittent failures. That's one of the hardest things on a development team is if your tests are not reliable. In our projects, any intermittently failing test, there's an issue created on it, and it's prioritized at a high level to go figure out why that test is failing intermittently. And those test completions should be regardless of the order the tests are run in. So whether you're doing a single test or you're working back out and you're running maybe just 2 tests from 2 modules in the whole test suite, order should not matter. The order of a test running should not affect whether it passes or fails. The environment it's running in should not affect whether it passes or fails. That is, whether it's an dev environment, if it's CI, if some of your developers use Windows and some use Linux, that should work, assuming your applications support that. Different dependency versions, you shouldn't have a developer installing one set of dependencies and a different developer installing a different set of dependencies. All of your libraries should be at the same versions regardless of what environment they're being installed in. We want to use generators to easily create random test data. So some of you may not be familiar, but there's generally 2 methods of getting data into to get your state of your application in the right setup for a test. And that is fixtures, which is often like just a bunch of data files that have all of the data kind of hard-coded in there, or generators, which are methods or functions that create random data for you. I strongly prefer generators. I find that fixtures are really hard to maintain, especially as they get bigger. If you can imagine a big application like the one that I said, if you can imagine, we'd have thousands and thousands of fixtures. If you add a required table at the core if you add a required field to a core table, you've got potentially hundreds or thousands of fixtures to update in order to adjust for that. And I personally have just not found that fixtures are maintainable. So we use generators for almost everything. The other thing you can do to make your tests an asset, not a liability, is to make them fast. We should be able to quickly run tests. We should be able to dig into particular tests, the ones that are failing, run those separate, and then be able to consistently kind of back out in concentric circles of the tests. So if you've got test runs that take 50 minutes to run, you're probably not going to run those locally. You're going to run tests just for the code that you're messing with. Make sure all of that passes, and then probably kick that off to CI and wait for CI to complete. So Remy asked in Slack, what's my opinion regarding test randomization to detect and suppress dependencies between tests? To be honest with you, I've never done that. I've never set up my tests to do, I'm assuming you mean there by random ordering. I certainly wouldn't be opposed to it. I think that might actually be helpful. Yeah. Okay, good. The other thing you can do, another thing you can do to make your tests assets is treat them like any other code. They're going to need good architecture. They're going to need refactoring over time. Yes, if you refactor your tests, you run the risk that you accidentally stop testing what you think you're testing. Just like anything else, you're going to have to be careful when you're in sensitive parts of the code. But don't get into the habit of feeling like you can't touch your tests. You know, if you start seeing better ways to test things, go back and adjust the other tests. Obviously, balance that with the fact that running tests are helpful and they're working. So if it's not broke, maybe you don't want to fix it. So again, there's a judgment call there that's needed, just like any other software. I have heard of Faker, yes. In fact, I'm going to recommend a tool called Blender later for random generation of test data for your database. Finally, the last thing that I think you can do, maybe not the last thing, but the last thing I'm going to cover in this talk that you can do is use a code coverage analysis tool. Understand what parts of your code are under test coverage and what parts aren't, and work on increasing test coverage by 1%, or if you get really big, maybe it's 0.5% or 1/4%, but you just want to constantly be increasing test coverage throughout the application's life cycle. And you know, if you're starting out and you're only at 50%, don't feel bad about that. You know, every time the test coverage comes through, don't look at, oh, it's only 51% now. Don't look at that as a negative thing. Look at the plus or minus column is what you want to look at. Hey, I increased it 1%, or I increased it 2%, or even I increased it 0.03%. Sometimes in our really big applications, we don't change a whole lot. And it goes up really small amounts. But what I want to know is, I just want to know that it's green. I'm increasing test coverage, and I'm not decreasing it. Okay, so that's the end of my introduction. Anybody have questions? Go ahead and raise your hand here, and or hit me in the Slack channel. No questions? Going once? Going twice? I'm seeing people typing in Slack, so I'll wait and see if we got some questions. How do you replace a fixture with a generator? That's going to be a somewhat specific context question, but the small or the short answer is going to be, it varies. It's just going to vary on your environment. What I would do is I would start replacing, maybe pick, like, you know, if you've got a database hierarchy and you have some stuff at the core and you've got some stuff more kind of down the graph on the edges, I'd start with one of those, like figure out how you want to do generators and just start with one of those. And once you get comfortable with it, then just kind of work your way up to the other generators and fixtures. And, you know, it might be, I've never done that. It might be that you can't do it, little by little, because your fixtures at the bottom are going to be, or your entities at the bottom of the graph are going to rely on the upper entities in a generator pattern. The lower entities would assume that the higher entities are taking care of creating themselves as part of the generator, kind of hierarchy. And so it might actually be possible that if the higher ones were using fixtures, the lower ones were using generators, that wouldn't work. So I'm sorry, I don't have a good answer for that. Okay, Maxim asks, what's a generator? So a generator is just a function or a method that, when called, is going to create an instance of in this case, a database entity that has random data filled in for the fields. So, you know, if you figure, let's say, you know, I've got a database order, the order has, 30 fields in it, and it has, 5 or 6 entities above it. Every time I'm interacting with an order, I don't want to have to construct all of those fields and all of that hierarchy. I just want to call like entity.order.testing create, and I get an order object. Because a lot of times in my tests, I only care about maybe 1 or 2 or 3 of those fields, and I'm doing something certain with them, and the rest of them don't matter to me. I have to have them exist for that record to be inserted into the database. Okay, so I'm going to take just a little bit of a break here and make sure we're going to transition over to the web application or to the tutorial at this point. I'm going to take about 5 minutes to see if you still have problems. Please post in the Slack channel. I realize there's some discussion above, but it's too much to keep up with. Yes, that's right, Michael. Don't confuse generators in this context is not the same thing as a Python generator. You might create a Python generator to create data generators, but not typically. So if you're still having problems with getting your the test repo up and running, go ahead and post here in Slack. What would be the best way to test an external database? So in general, and we're going to cover this in the tutorial, but in general, if you mean external, like shared and maybe like on some remote location, I would advocate not to write your test that way. External meaning like local to my environment. And I would say there's two primary principles. One is the application destroys and recreates the schema every time your test runner starts, and we'll see that here in the demo. Then number two, the entities themselves and the tests are responsible for creating the data that they need to get their state set up, and we'll discuss that in more depth too. So I am not an advocate for mocking out the database. I think the database is just too crucial of a part of the application to try to mock it out. I think you're going to spend way too much time doing that. So I just have a local copy of the database and recreate it from scratch every time the tests start. And then the tests are responsible for inserting the data they need to run. Okay, so I didn't see anybody posting with problems in the repo. So I'm going to go ahead. Oh, yes. Miles mentioned that the comment that he's getting from the tests is 11 passed, 1 skipped. README mentioned 10 passed. Yep, that's my fault. I just didn't update the README, but that's what you should see. 11 passed, 1 skipped when running the tests. Okay, so give me just a second to get myself squared away here. Let's see. How's that for text size? Anybody need it bigger than that?
No, it's cool.
Very good.
Okay. Give me just a second. Working on getting my desktop set up here. Okay, so to start here, I'm in the directory of my test that you have all checked out. I do want to point out, I have now pushed, there's a complete branch where I've actually gone through and you'll see exercises in the test files. I've actually gone through and completed those myself. When we get to the section where I'm going to give you time to work on the tests, I'd encourage you not to jump to the completion and actually work through them. But I realize that some of you may not have enough context to even know how to get started. And so I didn't want you to be sitting there just kind of bored and not really knowing what to do, waiting for me to jump back in. So the complete branch is there. My recommendation would be to open that branch on GitHub. So you can easily do that in GitHub by moving to branches and then moving to complete. And then you could scan through the code there. You could obviously check out that branch locally, but then you're going to have all of the solutions. And so it may not be as easy as following along with what you're going to see me working with. I did also try to make the commits in the complete branch pretty logical. So you should be able to look through the diffs and kind of see from diff to diff what the changes were that I made to try to understand them, try to understand them logically. And I may very well jump over here to GitHub and look at some of that stuff with you as part of explaining what I've done. Let me make this bigger. Okay. I think we're ready to get started. Anybody having problems with my screen share? Okay. So my Docker Compose is up and running, and I should be able to run all of my tests. The reason there's a couple skipped tests is because some of our tests that were here in the demo, they're failing. They're deliberately failing for a reason. There'll be some work that you need to do to not make them fail. But I never like to leave a failing test in a situation like this, because when you check it out and you start running the code, you're not sure if it's failing, if it's due to you or it's due to me. So if I let it fail, but then I skip it, that's a good declaration of intent. You should know as you see that, okay, I've got some skip tests. You're not wondering if your environment has some problems. That is a demonstration of how you want to treat your tests in your actual real projects. You never want to leave your fellow developers guessing about whether or not the problems that they're seeing are their fault or are actually something expected in the test, in the application. And so use skip tests if you've got a test. If you have a legitimate test, hey, it's broken, I know that it's not a big deal, but I can't fix it right now, then skip it, commit that skip. And what we would do then in my organization is you would then go file a test and explain that the test is skipped and why, and then that would be usually a high priority fix to come back and fix the test. Or if the test is broken and it's not going to get fixed, to just remove it. It's also okay to remove tests when they're no longer valuable. Okay, so a little bit of discussion here. All of the test files have, since this is a best practices, I have best practice principles here, and there's a number listed as we work through these files. So principle number one is just get started, even if it's something trivial. Interestingly enough, I had a really hard time preparing for this tutorial. I've probably spent, in the last 4 days, I've probably spent 20+ hours trying to put this together. And it really didn't start coming together until yesterday. And the reason for that is because I realized as I was working through this, so much of my best practices are ingrained in me. I just didn't know, I had a hard time. Sorry, give me a second. I had such a hard time remembering, like, what are the principles that I use, because they're just so ingrained to how I program these days. And then I had a really hard time figuring out how I was going to structure the talk so that it wasn't just me doing 3 hours of monologue, but there was actual opportunity for learning and working with the code, because I found that that's how I work best. And I had the hardest time just figuring out where to get started. And so this is a real test. This test number 01, all good, was the first real test I put together that finally got me kind of over my writer's block. And so especially when architecting a new solution, I'll often create very simple tests at the beginning that just get my wheels working and give me something to start with. And then I frequently iterate on that solution until it gets closer to what I think I need. But just getting something in the editor is often very helpful to me. Okay, so principle number 2. This is, if you're not familiar with the Zen of Python, you definitely should check it out. The Easter egg way to do it is that way. You can also just Google Zen of Python. And one of the options here is explicit is better than, or one of the principles here is explicit is better than implicit. So we definitely believe that that's true in our tests. And we have two types of tests in this application. We have CLI tests and we have web tests. And both of those in Flask require that you make a bit of an adjustment to make sure that your tests, your exceptions, if you get them, are not being hidden and making troubleshooting harder. So I just want to demonstrate that. We'll go ahead and run these tests. Let's see, show what this looks like when not caught. So okay, so if we go look at the code for this, here's my command. So this is, in case you're not familiar with this pattern, this is Click is a library developed by the same organization, Palettes, as Flask is, and Flask uses Click to help build CLI commands. So I've got some of that wired up here. I'm not going to explain how it works. You can just trust that if we're in the CLI file and we type error on the command line, this is getting this exception. And so just showing what that would look like from the command line, it would look like flog error. And so you'll see that these exceptions are the same. That's what we want in our tests. In my test, I don't want a different error than what I would get if I was going to run the command for real. Unfortunately, Click's default test runner is, let me find it, is set up to hide your exceptions by default. Oh, I guess I don't have to do it there. I can just do it here. Okay, so as a reminder, the way the test was set up, yeah, so there I'm not even getting an error. So I'm calling it, but it's catching the exception. So what I'm actually getting here, oh, look at that. I did it a little bit differently. I did it here. So this is actually giving me the result as a return value. And then I have to test for it. So if I was going to do this, for real in production, I would definitely want to use the catch exceptions equals false method. And because that's my default, I actually set up an integration here where when I create my application, you can set a custom CLI runner. And so we created in this application a custom CLI runner that does two things. A, it sets catch exceptions to false. And then B, it sets exceptions to false. And then B, it changes the signature here a little bit. The actual invoke method takes a single argument of args that's supposed to be a list. I like the ergonomics of just being able to write the commands. I'll show you that later, but this is essentially in the same way that I would write a CLI command, I would write flog and then space and then error. I'm setting up the invoke method to have the same signature. So I find that that's a really nice ergonomically as a developer. It looks like what I would type on the command line. So I've made those, I've made that little bit of customization there to the CLI runner. So that's the CLI runner that will hide errors on you if you don't fix it or set it up manually. I just get tired of writing this every time I run a dot invoke and then forgetting it sometimes. Actually, it would be this if I was going to do it without the default. So I changed the default to match how I like to do development. And then the other error that we have or the other way that things can be hidden sometime is actually the Flask web request will hide errors and return 500 status codes. And so by default, the way that our tests are set up, again, is that you're going to see the exact exception that came through when you run the code. And so this is now coming from a different location. Note that's coming from the view. It's the same exception message, but it's the view now. So if we go and look at our views, it's just the same exception. And that's what I want to see. If my test actually fails, that's what I want to see come up in my tests. I don't want to see a 500 status error. I want to see what's the exception, because if you let your code wrap those exceptions or do different things with them, you lose the context, like what actually caused the exception in the first place. And so by not wrapping those exceptions and letting them bubble to the surface, you see the reality of what is causing the problem. Okay, so for Flask automatically stops that error handling when you're in testing mode. So in the application, you'll see that when we send in testing equals true, which we do when we set up our app, the testing mode gets set in Flask, and that makes Flask automatically raise those exceptions in a request context. Because that's how it works by default, I had to set up a custom app and client here. I can't use the web request. I can't use the default web request because it's automatically set up to expose those exceptions. Okay, any questions on exceptions? Explicit is better than implicit, or what I'm doing here with the CLI or web requests? Go ahead and raise your hand or Slack me. All right, gonna wait just a minute here. All right, doesn't look like we have any questions. Good to go. Okay, moving on to test 3, which is the first place that you're gonna get some exercises. Okay, so just to give a little bit of background to this. If you're not familiar with Hacker News, you should be. It's a great place to keep up to date with. Oh, well, I got set up because I check it too much in work. But you can check out hackernews.ycombinator.com. We'll give you a great place to check and maybe waste too much time, so be careful with it. Just kind of keeping up to date with news that's often interesting in the software world. They also have an API to get access to their data, which I like to use for demos because there's a lot of it and it's free, and there's not there's probably some rate limits, but they're nothing I ever hit. Okay, so this is my user and this is my data. This is actually returning a JSON response. You can see the raw data here. Firefox is being helpful to me in turning that into a pretty view. And in particular, you'll see that there's a karma. Hey, that's interesting. My karma's 404, not found. Okay, so you've got my karma and you've got the number of items that I've submitted there and their IDs. And those are the two fields that we're going to pay particular attention to here in these testing, in the tests. So let's go ahead and start off by running the tests. Okay. So we've got a few principles here. The first one is that we want to make our tests as close to the real world as possible. And by that, I mean that if I can simulate the browser, what the browser is going to do with my page, that's better than not simulating it. Then again, we have another principle about make things fast. So for me, if I don't need JavaScript, I'm not going to jump to Selenium. I'm going to use the testing client that is here. You've already saw an example of that in the last test. I'm going to use the testing client to basically make a browser request internally, so it doesn't actually go out over the network. It just uses WSGI internally to send a request to the application and then take its response and turn it into something that's easy to use and parse. But there's also different ways to do that. And so you'll see here as I start to walk through the exercises that we've actually got a bug, even though these tests pass. I guess I'll stay here. Even though these tests pass, if I run my browser, oops. Okay, so I actually, when I submit my request, I actually get a bug, and so there's a bug that our tests are not catching. So as exercise number 4 down there, we're going to use a different test runner that acts a little bit more like a browser to help us clean up those tests and find that bug and fix it. Principle number 4 that we're going to cover here is that it's helpful to refactor code to make it easier to test. So if we look at our view here, you'll notice that we do everything in the view. We get the form from the post request. We have the URL baked in. We go ahead and request our JSON, make our web request, turn it into JSON. We process the number of submitted items, and then we return a string. We return a string here that gives me a little bit of information about the user. And all of that's done, all of that's baked into this view. The only way to get at it is to run the entire view. That's the only way for me to get at it. I don't have separate functions right now that I could exercise as unit tests. These are more integration tests because I'm having to run an entire internal web stack in order to get access to this code. One of the best principles that I have found is to promote complex code into library functions that don't assume any kind of context. They don't assume a web context. They don't assume a CLI context. They don't assume they're running in Celery workers. They just kind of exist there in Python, and then you can wire up those core library functions wherever they're needed. And so I've started some stubs here that'll be part of what you're going to do to break out this code and make it easier to test. So let's walk through the tests first. You've probably seen that I'm using this web. This is a pytest fixture, so it's a web fixture. And you might have a question if you've never seen this before. Where does this come from? How do I get this? What fills this in? And the answer is this is a feature provided by pytest called Fixtures, and it's a handy way to kind of create and do dependency injection to create objects that I need to run my test based on what I need to run my test. So I'm not going to go into what this app.test client is. You can read about that in Flask's documentation. I think maybe I had that in an O2. I guess I didn't, but you can Google Flask test client, and you can get a sense of what that is. It's just going to give you a browser-like object that you can make get or post requests on and other verb types. and interact with your web app like it's a client, or interact with your web app like it's a browser. So I do what this does is this creates that client object, and then I do a GET request. So this is a GET HTTP request. This is the URL. I check that my response has a 200 status code, and then I check that the text that I'm expecting ends up in that. So basically, that test does the exact same thing that this page does. It just loads this web page, and then I can do some validation on it inside the test. So this is my GET, and then this is my POST. Unlike the browser, at least using this method, I'm not kind of clicking a go button here. I'm not submitting the form. I'm just manually doing both sides of it. This is my GET request. Excuse me. This is my POST request, and I'm having to feed it the data that I would expect the form to have when I fill out this when I fill out this field. Status code 200, and then I'm testing to make sure that the Hacker News returns the same values that I received when I pulled it up in real time. So our Syring 404 and submitted count, I'm not going to count those, but my testing earlier demonstrated that there was 102 submissions. So that's why I have that string. And when I run my tests, they pass, which tells me I still must have 404 karma and 102 submissions, because that's what I'm testing for. Okay, so if it's not clear, this test is actually going out and making a live web request to the Hacker News API in my testing. So somebody raise their hand and tell me what's problematic about this test. What makes it? What makes this test a liability instead of an asset? Yeah, Adam, go ahead.
If their API changes, this test isn't gonna work the same way. Or I guess
Yeah.
well, that could actually be good though if your test fails. So you'll know that the test is failing. So maybe not.
Yeah. So that actually brings up an interesting point. So to your first point, you're close. Yes, if the API structure changes, that would fail. But the more concerning thing is that it would be pretty easy. Like all I have to do is go make a comment on some Hacker News thread, and all of a sudden this test is going to start failing, and there's not going to be any thing in the code. Like all of a sudden it's going to be passing, and the next time you run your test or CI runs it, it's going to be failing. So this test depends on an external system state. And that's problematic. We don't typically want our tests to do that. Adam, you made an interesting point though, because you said, well, but it might actually be helpful to know if the upstream, API structure changes and broke it. And if what we're going to do is we're going to learn how to mock out these API calls. If you mock that out, your test could actually pass when in production they would fail. That's actually true. And what that helps to surface for us in this discussion is that you have different types of tests. For our purposes, the tests that we're doing are integration tests and unit tests local to the system. You might actually have a completely different set of tests that exercise your third-party API and give you kind of a heads up if anything on there breaks, but it would be a completely different type of test in that case, and not subject to the same best practices that I'm discussing here. Another Adam posted on Slack that if Hacker News is down, the test will fail. So normally at this point in a live conversation, I would stop my network, I would kill my Wi-Fi, and I would show that the test fails. But obviously that's going to be problematic for a remote tutorial here. So I'm not going to do that. Okay, so let's. Any questions about what we're doing here, about how this works, about how the clients work, or how the tests work? Go ahead and raise your hand or send me a Slack post. If you're waiting and you want to read ahead and start working on some of the exercises, I'll explain them here in a bit, but I'm going to wait for questions. So if you want to work ahead, feel free to work ahead and start working on the exercises that are listed here in the comments. Okay, so yeah, so lots of questions about the libraries and how they work. I'm hoping that the exercises that I've given won't delve too deep into the actual libraries. You won't have to go learn a whole lot, not related to the testing. But I realize that if all of this is unfamiliar to you, yeah, it may be a lot to learn. You'll just have to try to kind of hang on. Okay, so I don't see any other questions coming through. I'm going to go ahead. We're going to take a 15 minutes here. So it's about 2 o'clock. So about 2:15, I'm going to come back and see how people are doing. In the meantime, I'm going to go ahead and monitor Slack. And if you've got questions, feel free to post your questions there. So first exercise, I've left in HN profile, I've left a couple stub functions there. And so your goal is to kind of break out this functionality into those 2 stub functions. I'd encourage you to do it in the order that listed there. This will give you kind of introduction to TDD. So write the test first, fill in those stub functions, and then refactor your view to use those stub functions. In that instance, the current test should not break. The second thing you're going to do is use mock. So I've left a link to the Python mock library and the patch function or method in particular. So use patch to mock out HN fetch profile. So this is the first step that you're going to take to remove the dependency on an external library, is by patching or by to mock out HN fetch profile. So that your view, when your view calls HN fetch profile, it's not actually calling the real HN fetch profile. It's testing a mock. It's calling a mock object. And you will have to read about some of that, read about the unit tests. The third step is to use responses here. Again, I've given you that library. Responses is a way to test, to mock out the request library. The request library actually turns out, as helpful as it is for requests to make them, it's not easy to mock out with the unit test mock tool. And so there's a different way to kind of set up your web requests on the back end, and responses is a really helpful way to do that. Finally, use the web test library. Again, link is in the bottom, to do better form handling of the tests. And that should expose the bug that's present here. So I said 15 minutes. This is really, as I'm talking here, this is really probably more like maybe a half an hour that I'll give to work through these things, and then we'll see where everybody is, and maybe give a little bit more time even after that. So the idea of refactoring and progressively mocking things out is one of the key principles to writing tests, is just knowing how to break up your code to make your test valuable. So we are going to spend a decent amount of time on that. As a reminder, or in case you've joined late, there is a complete branch in GitHub, and I've got all of my commits there. So if you want to see how I did some of this stuff, you can certainly walk through it and get a jump start on your exercises here. So with that, I'm going to mute myself. And if you need help, please turn to Slack. It might actually be help to do some reverse screen sharing, potentially for people who are struggling. That seems like it also might be very distracting. So I'm not sure how to balance that. I guess we'll just play it by ear. And if the conversation is bothering you, just mute yourself for a bit. And I won't say anything important for at least another 25 minutes. We'll come back at 2:30 and kind of see how everybody's doing. Thank you. All right, hope everybody enjoyed that exercise. I am going to go ahead and move on to the next test. I'm not going to review what I did for mine, since you have access to the complete code and can take a look, but I will review it after this next test, because the two are actually related. So I'll kind of review my solution to both. So this next test is going to review, is going to focus more on CLI commands. And then what we're going to do is we're going to see that as we realize that the same functionality can be used in more than one context here being the web context for one, the CLI context for another. CLI context often comes into play. We often schedule our web applications to run cron jobs. And so the cron jobs are usually calling into our application using a CLI context. Now you can also have Celery workers. Celery workers are a different type of context that calls in to the library code. And so the library code usually wants to be context agnostic. So this is principle number 6 here. It's often useful to create CLI commands that make it easy to run library code. So as the app exists currently, the only way that I have to exercise the Hacker News library is to load a web server and submit the form. It makes sense to me that I would also be able to call that same library code from a CLI command. We have one application that we developed that I'm a big part of for horse race betting. Our client develops the algorithms, and then we maintain a somewhat complex system to interact with all of the systems to get him the data in real time and submit his wagers. And there's a lot of places where you have a heavy amount of functionality kind of buried in. It's just kind of, it's buried very deep, and it would be very difficult. So for instance, when the wagering API, in production, the way to wager is we receive a authenticated web request, an API that tells us what the wagers are supposed to be, and then we go wager them. Well, it's also helpful for us. We have multiple environments. We have a production environment, we have a beta environment, we have a dev environment. The dev environment is the only one that we can test wagering on, because otherwise it's real money. So if you want to test, 1,000 wagers running through, you can't do it in the production or the beta system. And so, we created a CLI command to issue wagers. A random number of wagers. We had a couple options in there for how to set up the wagers. And that was a really easy entry point to us, for us to go to the development system and exercise some of our code. Once we had all the tests in place and we actually wanted to go to QA, we have a number of CLI commands that we can run as developers in the dev and beta systems, and sometimes in production, in order to help us just exercise code and make sure once we have the tests in place that it actually works out in the real world. So principle number 6 is CLI commands often give you a good way to validate that your library code does what you think it's doing from a QA perspective. A lot of time, most of the time, you want your library code and data structures to be context agnostic. So for instance, I wouldn't want the Hacker News profile code, library code, to go out to flask.request and fetch the username from the request, because that's only valid in a web context. That's not how you would do it in the CLI context. So you want to pull those context aware operations into the view or into the CLI code, and you want the library to be more pure than that. And so if you're used to functional programming, as much as possible, you're working towards an actual pure function where you've just got input and output, and you don't have any side effects. Although honestly, in Python, for things like SQL, alchemy, and APIs, you're going to have a hard time getting pure functions, but you're working with some of those principles in mind. Principle number 8, sometimes it makes sense to share library code and make it adaptable to the context. So you're going to see this in exercise number 8 here, as I refactored the code, I realized that there was a number of similarities in the code. And so rather than repeat those similarities over and over again, I went ahead and put a little bit of context awareness into my library function, which was do you want me to style this as using HTML or not, so that the web view gets HTML and the CLI view does not. It turned out that that really was the better architecture and resulted in less duplicated code for just a little bit of extra logic in that library function. So sometimes it does make sense to make the library code context aware and do different things based on the context. Principle number 9, it's really easy to only test happy paths. Don't do that. Test the unhappy paths too. And by happy path and unhappy path, I mean, as a developer, my job here was to go out to the Hacker News API and fetch data and return it and print some of the stats. That, as long as that works, I'm good. Well, but the unhappy path is error handling. What happens if the username that I'm given isn't actually a valid Hacker News username? And so I want to take some of those unhappy paths into consideration. So here's your exercises. So we're going to refactor the view code from the last exercise, and we're going to put it into a Python module dedicated to the Hacker News library functions. And then we want to make sure that when we're done doing that, the exercises, the tests from the last exercise should pass. So we should be able to refactor the library, put it in a different file, and we shouldn't have to touch our test from test 3. Then we want to go ahead and create a new CLI command that makes the tests below pass. And so the tests below are a new Hacker News profile CLI command. And when you pass in the user, that would presumably go out to the API, fetch those stats, and print them to the CLI. Once you're done with that, you should also, again, your tests from the last test should continue to run. There shouldn't be any breakage. And then number 5, your manager asks you to change the output of the Hacker News profile web view to bold the username. Go ahead and make the change and adjust the tests. Depending upon how you decided to build your library tests, if you just return data and formatted it in the view, there shouldn't be a whole lot that you're going to need to change here. If you did it like I did, which is I made the library view actually return the string, then now I've got to decide how to handle that because one string needs to have HTML, the other string doesn't. So once you get that fixed, run the browser version for the Flask server as well as the CLI version to make sure that your code works for real. Notice I'm not running it in production until I've got my tests done. So I'm trying to do TDD. I want to write my tests first as a representation of how I think it's going to work. And then I'm going to do some QA to manually test at the end, assuming all my tests pass, to make sure I haven't missed something in my tests or a bit out of sync with reality. The next step is then going to be to properly handle an invalid username. Currently, you're likely that your library functions will just throw an exception if you get an invalid username passed in and you want to change that to handle it better. And then number 8 is maybe another refactor as you realize there's a lot of duplicated code, and maybe it would be better to have that library function just be aware of returning HTML or not HTML. So a bit of work to do here. Any questions? Go ahead and raise your hand or give me a Slack message if you got a question. Yeah, Adam, go ahead.
How do you identify something as like an entity or a service or something as being good to mock, or to just hit the live version, or should you always just mock it?
Yeah, I would never advocate for not a test like this, not a test that's supposed to run like automated test suite, where you're
Mhm.
not deliberately testing the third party to see if they've changed things on you. I would always recommend avoiding hitting the third party service and mock, or, you know, sometimes you might have another option like the database server. We're not going to mock the database server out. But usually web APIs like this, you almost always have to mock them. You don't really have any choice. At least I've never come up with a good option, you know, other than doing it this way.
Okay, thanks.
Sure. Brandon Gaddy, go ahead. Or not.
So,
go ahead.
Oh yeah, so wouldn't we really want to move some of these tests out into some integration testing space? Like, it seems to me you'd want to unit test without hitting the APIs, just to see that your processing of the data is correct.
Yep.
And then you would do integration testing, but then, you know, that makes things more complex.
So the difficulty is when you say integration testing, that can span a really broad range. Like, I consider tests that interact at multiple levels in the application integration tests. So when I start, like anytime I would do one of the view requests where we're using like web.get, to me, that's an integration test. When I'm testing the application with a web request and letting it kind of run all the way down the internal stack and all the way back up to a web response, that's a type of integration test to me. It's not a unit test. Selenium would be an even kind of higher level integration test, right? Like, I'm not even staying inside my own process now. I'm actually seeing what the app is going to do in a web server. And then you could go a step further and you could have tests devoted to exercising the third-party API, maybe in some kind of sandbox that they've set up for you to make sure that they're not accidentally breaking the API. And a lot of that decision is just going to be how much resources you have to devote to testing and how much you trust upstream. If you've got a really critical process and they're constantly changing things and breaking on you, I'd have CI that, you know, kicks off every 30 minutes, you know, a full test suite of some kind of sandbox or some kind of junk account, just to make sure that I know exactly when they break something on me. But to be honest with you, I've been doing this, you know, I said going on 15 years. For the stuff that we've done, I've never had a need to set up an integration test like you've described. Most of the time, the APIs that we're working with are stable enough that we can just assume that they're going to be reasonable, responsible API citizens, and we just run our tests based on kind of the contract and the documentation. And if they break something on us, you know, we have good monitoring, exception monitoring in our systems, and we know about it. We go fix it.
So you wouldn't mock it at a low level to test your data processing logic, and then actually test it at a higher level to make sure that the connection is still good. You would still just cram it all into one go and
No, sorry, I wasn't clear. No, I would test only the mocked version, and I wouldn't worry about any kind of live integration testing.
Oh, so all the tests that we've written here that actually go out to Hacker News, you wouldn't actually do?
No, I wrote that as an example of a brittle test. Like, when you're done doing these exercises or you look at my complete code, there's nothing that actually goes out to Hacker News. Everything should be mocked.
All right, so that was completely lost on me. I haven't looked at your complete stuff yet, but okay.
Sorry. Yeah. So the whole point of these exercises, or the whole point of the last of test 3, was to stop testing the live service and to mock it out using different methods. So one method was to mock out the HN fetch profile command, and then the other method was to use the responses library to actually kind of fiddle with the requests internals to kind of go at a deeper level mocking. Okay. Is that good, Brandon? Any follow up on that?
Oh yeah, thanks. I just will say I'll have a look at it. Thanks.
Okay. Anybody else questions? Let's see if I got anything in Slack. I've been looking at Zoom. Nothing in Slack. Any other questions so far? So again, I left a little bit of commentary in my in Slack on my solution. In the end, I came back to let's see. Let me share my screen. I'm sorry, I forgot to do that last time when I was talking about this. Okay, so if we look at my, if we look at this, oh, that's not. So I did end up going back and changed my profile. I added a new function for profile stats that actually does the fetch. And since that's going to be used in two places, I gave myself an option. Do I want to return HTML or do I not want to or do I want to add HTML or not add it? That was easy enough to do in here. It's very possible that you had a function that is heavily context aware and it doesn't make sense to do that. But in this case, I basically repeated this exact same, I had this exact same code in two different places. And so I wanted to dry it up some and I dropped it in. So I dropped this profile stats here. And so if we look at my CLI command, it ends up becoming just really easy, just a call to that profile stats command. The CLI says don't use HTML. The view says do use HTML, and we're off to the races. And I don't have any code duplicated. Okay, so let's go to test 5 here. Let's start talking about email. Okay, so what we've learned, hopefully what we've learned, I've realized now that I'm working through this, that there's probably a lot of stuff to do and you may not have been able to finish it all. But mocking ends up being a really useful, but also a potentially abused tool. And so learning when and where and how to mock, you probably can't spend too much time trying to learn how best to architecture your mocks, where you mock something, what you mock, when you use mock, when you should try to use something else like dependency injection, in which case you still might want to pass in a mock object, but you won't be using .patch. So I'm not going to go into that, but I am going to say that sometimes we have multiple options for how to deal with an external services. So in test number 5, having to do with email, we are going to create a CLI command that basically just sends us an email as an example of, internal functionality that would do that. And we want to, there's going to be 3 different ways to mock it. One way is going to be to, this is your exercises, use mock.patch to prevent the email from actually sending. The second one is to use the internal facilities baked into Flask Mail. If you look at Flask Mail's documentation, it'll teach you something about an outbox, how to use that for testing. And then the third option is to actually set up a fake SMTP server that gives you the ability to see the mail and has an API to query it. So just to show you what that looks like, I am going to flog, I'm going to run this mail randy at thesyrings.us. Okay, so that shows me the email was actually sent. The output's kind of annoying, but it's there. So the email was actually sent. And now in your Docker Compose file, this was actually set up. This fake SMTP server was set up as part of Docker Compose. Notice I mapped port 25 on my local host to 1025 on that server. So by default, Flask Mail is going to use the default SMTP server of port of 25. I don't have anything else running on my system on port 25, so I can do that. 1020, it's going to map it to 1025, which is where fake SMTP server is listening. Fake SMTP server also has a web interface available on port 1080. So we're going to go look at that just so you can see what that looks like. So those are the test emails that are in there. Just to show you, if I added a different one. Okay, so so you can see that we now add another email, and then it also has a web API that will show me all of the emails. And you probably have a hard time seeing that, but that's pywebexample.com. So that's the email. So the idea is this SMTP server doesn't actually forward the email on. It doesn't actually send it out to the real world. It just kind of catches it. It lets you query it, and it lets you clear things out. So the first exercise is to use mock.patch. The second exercise is to use the outbox functionality that's baked into Flask Mail. And then the third way that we could test this is to use the fake SMTP server and then query its API to see if the mail actually made it to it. This is the first time that we're having to deal with this principle of tests are responsible for managing expected state. So one of the things that you're going to want to do in testing is you're going to have to decide, when you have shared state, who's responsible for setting up the state so that the tests pass. Usually there's two fundamental ideas. Either A, you set up the state beforehand, or B, every test has to clean up after itself. I like to keep like my code with knowledge closest to itself. And what I mean by that is like when I have a test, when I'm writing that test is when I know what the state of the world needs to look like. And so I like to have the responsibility on prepping state. So if you think about it this way, that could mean putting the right data into the database. In this case, it's going to be making sure that the emails that are in the email server are only the ones from this test. So I'm not accidentally pulling out an email and testing it from a different test that ran before mine. Both database state, so one's database state, one's email state. It's during the test that I know most what I need the world to look like. And so at level 12, our standard is that a test is always responsible for setting up the state or clearing it itself. And so if it breaks because of another test did something, it's not that other test's fault. It's its fault for not prepping and making sure that the state was in the way it needed to be. And then the third principle here we're going to use for number 3, if you get to it, is to use a Flask fixture to clear all the queued emails for the fake SMTP server to avoid cross-test contamination. So again, theoretically, we're going to write a test here. We're going to hit that API. We're going to make sure that only one test email was sent, and then we're going to examine the attributes on that email to make sure it matches what we assume that we sent out. So any questions on this? Go ahead and raise your hand or ask here in Slack if you've got a question. Okay, gonna move on then. For what it's worth, I use the outbox method. I think that's the mocking can get kind of brittle. I was going to show that, but I'm kind of running out of time. But I would use the outbox method. I wouldn't normally use the external service. If you notice, that external service adds about a second for that test, the third test in my solution. And if you can imagine, if you had throughout the course of your application, if you sent 50 emails, you'd be adding 50 seconds of time. Obviously, you could try to work to find a faster solution. I'm not sure why that server, that fake Smtp server, is so slow. But I don't think you need to add that latency. I think the outbox method usually works just fine for most needs. Okay, I'm going to share my screen here. Okay, so I am working on test 6. So a reminder from the email test that tests are responsible for managing their expected state, usually at the start of the test. If you're working on the base still, you should notice that this has been updated a little bit, but you should notice that the test post has been commented out. It's been skipped. I'm sorry, it's not been commented out. It's been skipped. The reason for that is before I added this, let's just run this test and see. I think that's going to show it. So the problem here is that when we test the comment creates a post because a comment is required to be associated to a post. So that puts one post in the database table. And then in test post, we add another one. But this test is assuming that it'll be the only post created, and it's not enforcing that. Again, remember that a test is responsible for enforcing its state. So if we're going to check and query that the count is 1, we're going to have to make sure to clear the tables before we start. So I do that here, ends.post.query.delete. And the reason I'm walking through this is because I realized that I gave the exercises, but I didn't finish it myself. So we're gonna do a little bit of live coding here. So this should take number 1, exercise number 1 is simply to run a query on a delete on post. And because we have a foreign key set up with an on delete cascade, PostgreSQL is going to make sure that our comments get deleted too. If we didn't have that, or we had a foreign key without a cascade, then we'd have to add a comment first, a comment delete first, and then need to commit that. So it might have to look like that if you didn't have the foreign key, but you don't need that. You do need the commit. Okay, so that's the solution to exercise number 1. I talked at the very beginning of this talk about generators, and we kind of had a question about what a generator is. So a generator is just a really easy way to create something. So notice every time I do this, it's a bit verbose, right? When I want to comment, I got to create a post. Well, if post actually had like 10 or 15 fields, this would just get really unruly. And in our actual real applications, it does. I mean, there would be no way to keep up with this. You'd probably have another 100,000 lines of code just setting up all the database entities to prep for tests. So we're going to add testing create methods. There's nothing special about this method. This is just the name that we use in our organization to indicate testing create to create or to indicate that this is the method that creates the object. And so I'm going to set this equal to quarks.get title. All right, so I'm hoping now I can get rid of all this stuff here and I can just do ends.post.test and create. Oh, that's supposed to be, this is supposed to be testing comment. And this will be post. I'm gonna show you one neat thing about, so I want to just test, I don't have my comment, I don't have my comments. I don't have test comment done. I'm sorry. I don't have test and create done here yet for comments. And so I just want to test the work I've done for post. So I can grab my file and I can use -K for post. And that should just select the one test. If I wanted to do a verbose, you'd see that, I guess I'd have to do VV. That's my test post. So I get that selection with the -K option. So post is working. Now I can be confident that I can copy and paste my test and create here. Same title, author, body. We need to make one change here because comments might get a post. And so we want to do post equals quargs dot get post or so we do this one a little bit differently because we don't always want to instantiate a new post if one's getting passed in. This is a little bit naive. There's actually in SQLchemy, you could also pass in a post ID and that would be sufficient. And so we would actually want to break this out. We would want to break this out a little differently, but I'm going to leave it. I'm going to leave it alone for now, just because we're running out of time. And I think this will work. So run the tests. Name post is not defined. Where was that? Line 31 is, yeah, I guess that doesn't matter anymore because we're assuming it's there. I guess we could do is comment.post. All right, let's see how that works. All right, so that's that gets us number 2 there. And then I'm not going to actually do the third exercise here. I just pointed a link. We have some of our other code set up so that you don't even have to do the majority of this. We automatically generate the random data based on the type of the SQLchemy column. And that can be really helpful, just not even have to think about most of this. So I put a link here to that code. You could go take a look at it, copy it, use it for yourself. That would be fine. So what questions does anybody have about anything here in the talk or anything related to automated testing? Well, I'm somewhat encouraged. We've only lost about 11 people. We only lost about a third. That was a pretty long venture to work through. I realized, kind of after doing this, that there was probably too much stuff to work through, and I maybe should have focused on picking 1 or 2 of these areas and not trying to get them all in. I will push up this last commit that I made here to the web repo if you want all the exercises completed, something you can refer to. I'd really appreciate any feedback you have on this format. I really debated on whether or not I just wanted to kind of walk through slides for 3 hours or actually give people time to do the work. I'd be interested to hear if you thought the other would be better, the other option, just to walk through it, and or what might have been the better exercises to work on here, and maybe the ones that could have been dropped to make your learning experience better. The truth is there's just a lot here. There's a lot to learn about how to test well. Hopefully I've exposed you to the ideas and given you some examples, and now you can go away and at least have the concepts and learn more about them. To be honest with you, I'd say it took me a couple of years to really get the groove of how to write tests. Don't get discouraged. Continue heading in that direction. They're absolutely worth it. I would not take a job in software development if I knew that I wasn't going to be allowed to do, if the company wasn't committed to testing. I would literally take a $20,000 or $30,000 pay cut a year just to work in this way. Cause to be honest, I don't even know how to work differently anymore. My brain just thinks in terms of testing now when I write code, and it's definitely an improvement over how I used to do it. Yeah, Gregory asked about resources for testing. I don't have any right off the top of my head that I can link to, but this is what I'll tell you. There's a guy named Ned Batchelder. He's big in the Python community. He wrote the coverage tool that we use in Python. He has a number of talks at PyGotham, which is a New York City Python user group, as well as PyCons. Anything that he's talking about testing on, I'd listen to it. He's going to be great. Yeah, and Devin said struggling with mock and patch. Absolutely, like everybody struggles with that. Understanding where to draw the lines. Don't be discouraged. Dig in. Read the code. Read the documentation. Understand what the docs say about how to do it, and then just go look for good examples and tutorials. That's probably your best bet. Thanks for the encouragement, Chris. Thankful for the exercises. They helped to see you how effectively mock things. Yeah, you're welcome. Any other questions? Feel free to raise your hand or post in Slack. Last thing here, I know in the software development world, everybody's got like their 2 cents about what you absolutely have to learn. There's a lot of hype. It can be especially discouraging around conferences like this, where you walk out and there's so much to learn, so much to do, so much you feel like you're bad at. And really the reality is maybe you can take 1 or 2 things away and work on them. If you're not working on automated testing, do it. I guarantee you, I promise you, it will pay dividends. It will take you some time, but if you can start doing it and get your head wrapped around it, it will absolutely be an asset for you in the future in your career. The second thing, if you've already got automated tests, but you don't have CI set up and it's not integrated with coverage, Circle CI is a great CI service. Codecov.io, wrap all that stuff into GitHub, get that stuff set up. Yes, it takes time, maybe a half a week, maybe a week, maybe 2 weeks sometimes, but having your test kick off every time you push something's great. I'm out of time here for the Zoom. Thanks everybody for joining today. I'll hang around Slack for a little bit and try to answer questions.